It's October 2007, Toulouse-Blagnac Airport. Airbus delivers the first A380 to Singapore Airlines amid champagne and camera flashes. The world's largest passenger aircraft, 471 seats, double-decker opulence, a flying hotel. Aviation journalists call it the future. Airbus executives call it vindication. But rewind 3 years. Boeing's boardroom, 2004. It just walked away from the superjumbo race entirely. Instead, it bet everything on the 787 Dreamliner, a twin-engine, mid-sized aircraft that does exactly the opposite of what Airbus is building. Two companies, two radically different visions of how people would fly. One bet on bigger hubs and massive aircraft. The other bet on point-to-point efficiency and network fragmentation. Only one would survive what came next. This is the story of how Airbus built a $33 billion monument to a market that was already dying, and how the most beautiful plane ever built became aviation's most expensive strategic failure. For over 3 decades, Boeing 747 held an uncontested monopoly. The Queen of the Skies wasn't just an aircraft, it was a symbol. Airlines that operated 747s signaled prestige, global reach, and financial strength. Routes serviced by the 747 were the most profitable in aviation: London to New York, Tokyo to Los Angeles, Sydney to Singapore. Airbus had no answer. Despite Airbus's gains in market share versus Boeing, the wide-body supremacy still belonged to the latter. The 747 dominated high-capacity long-haul. The 777 was rewriting the rules for twin-engine range and economics. Airbus had the A330 and A340, but neither could touch the 747 or the 777's combination of capacity, range, and brand power. The strategic imperative was clear: break Boeing's stranglehold on the most profitable routes, build something bigger, build something better. The A3XX program began in the mid-1990s as a direct 747 killer. Airbus studied the market and saw continued growth. Air travel was doubling every 15 years. Mega hubs were emerging in the Middle East and Asia Pacific. Airports like Dubai, Singapore, and Hong Kong were becoming global connection points, funneling passengers between continents. Airbus made a bet, a big one. The assumption behind the A380 was simple: passengers will tolerate connections if it means flying on the biggest, most luxurious aircraft ever built. Airlines will prioritize hub efficiency over point-to-point convenience. Airports will invest billions to accommodate larger aircraft because the traffic growth justifies it. The logic seemed bulletproof. Slot-constrained airports like Heathrow couldn't add more flights. The only way to grow capacity was to fly bigger planes. An A380 could replace the 747 and deliver more passengers per departure while using the same precious runway slot. The business case was built on hub-and-spoke economics. Major carriers would funnel traffic through central hubs, filling 500-seat aircraft with connecting passengers from dozens of spoke cities. The per-seat cost would be lower than any competitor. The passenger experience would be unmatched. Airbus projected demand for over 1,200 aircraft over 20 years. The numbers justified a development cost exceeding $25 billion. European governments backed the program with favorable loans and subsidies, viewing it as a strategic industrial investment. But the bet had a hidden flaw. It assumed the future would look like the past, that hub dominance would continue, that passengers would accept connections, that four-engine economics would remain competitive. None of those assumptions would hold. While Airbus was delivering the A380, the aviation world had already shifted. Boeing was working on the 787 Dreamliner, a medium-capacity, long-range twin designed for point-to-point services. Airlines were already discovering that passengers preferred non-stop flights with the 777, even if it was a smaller aircraft. The 747 had dominated because twins couldn't fly long over water routes, but ETOPS changed that. Suddenly, 777s could fly Sydney to Los Angeles non-stop. The hub model started fragmenting. Airbus didn't see it coming, or if it did, they believed the A380's advantages would overcome the shift. Superior passenger comfort, lower operating cost per seat, the prestige of flying the world's largest airliner. It was building the ultimate hub aircraft for a world that was moving away from hubs. Building the world's largest passenger aircraft required more than ambition. It required a complete reinvention of how aircraft are designed, manufactured, and assembled. The specifications were staggering. 2 full-length passenger decks, seating for over 500 passengers in typical configurations, maximum range of 8,000 nautical miles, wingspan of 79.75 meters, so wide it required new taxiway spacing rules at airports worldwide. The structural challenge was managing weight without sacrificing fuel efficiency. Every kilogram added to the airframe meant less payload capacity or shorter range. Airbus turned to advanced materials, extensive use of carbon fiber reinforced plastics, advanced aluminium alloys throughout the fuselage, thermoplastics in secondary structures. The result was an aircraft that weighed 391 tons empty, but could carry 575 tons at maximum takeoff weight. The wing design alone was an engineering marvel, nearly 80 meters from tip to tip, requiring airports to widen taxiways and create special parking stands. The wings incorporated advanced aerodynamics, curved wingtips that reduced drag, complex flap systems that allowed steep approaches into noise-sensitive airports. Engine development became a parallel challenge. The A380 needed power plants capable of producing over 70,000 pounds of thrust each. 2 options emerged. Rolls-Royce developed the Trent 900. Engine Alliance, a joint venture between GE and Pratt & Whitney, created the GP7000 engine family. Both engines pushed the boundaries of turbofan technology, incorporating advanced materials and digital engine controls. But the real complexity was in assembly. Airbus had built a pan-European manufacturing network. Wings came from the UK, fuselage sections from Germany and France, horizontal stabilizers from Spain. Each component was built to exacting tolerances, then shipped to Toulouse for final assembly. The logistics were unprecedented. Airbus created a custom roll-on, roll-off ship called Vie de Bordeaux to transport fuselage sections by sea. Overland convoys moved components through French villages on specially widened roads. The final assembly line in Toulouse was a cathedral of aerospace engineering, massive jigs holding aircraft sections, while thousands of workers installed systems, wiring, and interiors. Then came the wiring crisis, a catastrophic production delay. Airbus had factories across Europe using different versions of CAD software. The digital models didn't align. When workers tried to install the wiring harnesses, nothing fit. Bundles designed in Hamburg didn't match the fuselage sections built in Toulouse. Connectors were in the wrong locations, cable runs were too short, or routed through non-existent pathways. The fix required manual rework, teams of technicians crawling through the fuselage, rerouting cables by hand, redoing months of installation work on every aircraft in production. The delays cascaded. Deliveries pushed back 2 years, penalty payments to airlines mounted. Airbus's stock price collapsed. First flight finally came in April 2005. The aircraft performed flawlessly, but entry into service slipped to October 2007, 2 years late. Airlines that had ordered early were furious. The delays were expensive. Development costs ballooned past $30 billion. Airbus needed to sell hundreds of aircraft just to break even on the program. The original business case assumed 1,200 sales over 20 years, but the aircraft itself was extraordinary. Passengers loved it. The cabin was quieter than any widebody in service. The ride was smooth. Airlines configured it with amenities no other aircraft could match. Onboard bars, showers in first class, spacious seating even in economy. The A380 succeeded as an engineering achievement. It set new standards for passenger comfort, structural efficiency, and aerodynamic performance. The real test wasn't whether it could fly, it was whether airlines would buy it, and whether they could make money operating it. Singapore Airlines took delivery of the first A380 in October 2007. The launch customer configured its aircraft with 471 seats, far below the theoretical maximum, prioritizing space and comfort over density. First-class suites with sliding doors, business-class seats that converted into fully flat beds, premium economy with generous legroom. The bet was on premium long-haul travel, Singapore to London, Singapore to Sydney, routes where passengers would pay extra for the experience of flying the world's largest airliner. But the true believer was Emirates. The Dubai-based carrier didn't just order A380s, it built its entire hub strategy around them. The initial order was for 58 aircraft, then 90, then 140. By the time production ended, Emirates had ordered 123 A380s, more than every other airline combined. Emirates saw what others missed. Dubai's geographic position made it a natural connection point between Europe, Asia, Africa, and Oceania. The hub model worked when you controlled the hub, and Emirates controlled Dubai. The airline configured its A380s for premium revenue, first-class suites with onboard showers and wood-paneled doors, business class with lie-flat seats and bar lounges. Even economy had more space than competitors offered. The economics worked because Emirates filled the planes, load factors consistently above break-even levels on key routes. Dubai to London carried business travelers and connecting passengers heading to Asia. Dubai to Sydney captured Australian tourists and expats. Dubai to New York served premium transatlantic demand. Emirates proved the A380 could work, but only if you were Emirates. Qantas ordered 12 aircraft, betting on much longer routes. Sydney to London via Singapore, Melbourne to Los Angeles. The Australian carrier saw the A380 as the solution for routes that required both range and capacity. Lufthansa ordered 14, Air France took 10, British Airways committed to 12. These legacy carriers were hedging their bets. Small fleets for flagship routes. London Heathrow to Los Angeles, Frankfurt to New York, Paris to Singapore. The optimism was infectious. Airlines projected continued growth in hub traffic, particularly in the Middle East and Asia Pacific. The economics seemed sound, lower per-seat cost on high-density routes, premium revenue from luxury cabins that no other aircraft could match. Korean Air ordered 10 A380s for Seoul Incheon hub operations. Asiana Airlines took 6, Malaysia Airlines committed to 6, Thai Airways ordered 6. But underneath the orders, warning signs were emerging. Most airlines weren't going all in like Emirates, they were buying small fleets, 6 to 14 aircraft, for specific routes. The orders suggested caution, not conviction. And some of the world's largest airlines weren't ordering at all. Delta, United, and American, the three major US carriers, placed 0 orders, not a single A380. The US hub-and-spoke model was already fragmenting. Airlines were discovering that passengers preferred frequency over capacity. 3 daily flights on a 777 generated more revenue and benefit than 1 daily flight on an A380. The A380 required perfect conditions to succeed: slot-constrained airports, high-density routes, premium passenger demand, hub dominance. Most airlines didn't have all 4. While some carriers embraced the A380, the world's largest airlines stayed far away. The reasons weren't immediately obvious, but they revealed a fundamental shift happening beneath the surface of global aviation. American carriers saw it first. Delta, United, and American Airlines ordered exactly 0 A380s, not 1. The decision wasn't about the aircraft's capabilities, it was about the market they were operating in. The US hub-and-spoke model was already fragmenting by the early 2000s. Passengers were voting with their wallets, choosing non-stop flights over connections even when it meant paying slightly more. Frequency mattered more than capacity. The rise of ETOPS accelerated this shift. Extended range twin-engine operational performance standards has been gradually relaxing since the 1980s. By 2007, twins could fly routes that previously required 4 engines. The 777 could cross the Pacific non-stop. The A330 could handle transatlantic services with ease. 4-engine economics suddenly looked obsolete. Twins burn less fuel, maintenance costs were lower, 2 engines instead of 4, operational flexibility was superior. If demand dropped on a route, you could swap a 777 for an A330. You couldn't just swap out an A380. The aircraft was too large, too inflexible. Point-to-point economics were reshaping route networks. Passengers increasingly preferred direct flights over connections. By the 2010s, airlines could serve secondary cities profitably with 787s and A350s, bypassing traditional hubs entirely, routes that would never justify an A380 but worked perfectly with medium-capacity twins. Then, there were the airport infrastructure costs. Operating an A380 required billions in investment. Reinforced taxiways capable of handling 575-ton aircraft, widened runway spacing, modified gates with dual boarding bridges to serve both decks simultaneously, upgraded ground equipment, pushback tugs, baggage loaders, catering trucks, all sized for the superjumbo. Most airports couldn't justify the expense, especially when the same investment could accommodate more frequent service from smaller aircraft. The flexibility problem became the killer argument. An A380 locked you into high-capacity operations. If demand weakened, you couldn't adjust. You either flew the route with empty seats or cancelled service entirely. A 787 or A380 gave you options: reduce frequency, shift capacity to different routes, adjust configurations based on seasonal demand. Boeing's counterbet crystallized the opposition. The 787 Dreamliner was designed for exactly the opposite strategy: medium capacity, long range, point-to-point service. Airlines could open new routes without building hub infrastructure. Tokyo to Boston, Melbourne to Dallas, city pairs that would never see an A380. Turkish Airlines became the poster child for this operation. Istanbul was growing into a major hub. Traffic was doubling. The slot constraints seemed perfect for super jumbo operations. Then, Turkish chose the 787 and A350 instead. The decision signaled something profound. Even fast-growing hubs were moving away from gigantism. The future wasn't about flying bigger planes, it was about flying more frequently to more places. The market was shifting faster than Airbus had anticipated. The assumptions behind the A380, continued hub dominance, slot constraints forcing larger aircraft, passengers accepting connections, were collapsing in real time. But for one airline, none of this mattered. Emirates wasn't just betting on the A380, it was building an empire around it. By the time production ended, Emirates had taken delivery of 123 aircraft. The next largest operator, Singapore Airlines, had 19. This wasn't a hedged bet, it was total commitment. Dubai's geography made it possible. The city sits at the crossroads of 3 continents: Europe to the west, Asia to the east, Africa to the south. A passenger flying from London to Sydney could connect through Dubai with minimal deviation from the Great Circle route. Same for Frankfurt to Bangkok or Paris to Melbourne. Emirates built its network around this geographic advantage. The hub model worked when you controlled the hub, and Emirates controlled Dubai International completely. No domestic competition, no legacy carriers splitting traffic. Almost every international passenger flowing through Dubai was an Emirates passenger. The A380 became the tool for exploiting this advantage. Emirates wasn't struggling to fill 500 seats. The revenue strategy was ruthlessly focused on premium cabins, first-class suites with sliding doors, onboard showers, and personal minibars, business class with lie-flat seats, and bar lounges where passengers could socialize at 38,000 feet. Even economy passengers had more legroom than most competitors offered in premium economy. The premium cabins generated a lot more revenue per seat compared to economy. On some routes, first and business class passengers accounted for more than half of total revenue, despite occupying less than 25% of the seats. This was the business model the A380 was designed for: high-capacity aircraft filled with premium passengers willing to pay for the experience. The per-seat costs were higher than those of a 777, but the per-flight revenue was substantially higher. Emirates also had an operational scale that no other carrier could match. By 2019, the airline was operating over 100 A380s simultaneously. That created economies that smaller operators couldn't achieve: dedicated maintenance facilities, specialized training programs, bulk purchasing power for parts and engines, ground equipment fully utilized across a large fleet. The paradox became obvious. Emirates proved the A380 could work, but only if you were Emirates. No other airline had Dubai's geographic position. No other carrier could fill 500-seat aircraft consistently on dozens of routes. No other operator had the willingness to commit so completely to a single aircraft type. Even Emirates began shifting its strategy. In 2019, the airline announced orders for 787s and A350s, not to replace the A380, those would continue flying for decades, but to serve routes that didn't need 500 seats, secondary cities, seasonal destinations, markets where frequency mattered more than capacity. The shift was subtle but significant. Emirates was acknowledging what the rest of the industry already knew. The A380 worked for specific routes under specific conditions, but it wasn't the future of aviation. It was a specialized tool for a specialized mission. Dubai to London would always justify an A380, but Dubai to Prague, Dubai to Copenhagen, those routes needed something smaller, more flexible, more economical. The A380 had found its niche, a very profitable niche for one airline, but a niche nonetheless. The aircraft that was supposed to dominate global aviation had become a solution for a very specific problem that only one carrier actually had. And then there were the airlines that tried the A380 and quickly realized they'd made a mistake. Air France was the first one to crack. The carrier had ordered 10 A380s, configuring them for Paris Charles de Gaulle to New York JFK, Los Angeles and Johannesburg. Premium routes, high-yield passengers, exactly the kind of service the A380 was designed for. By 2019, Air France announced it would retire the entire fleet permanently. By 2022, not mothball, not temporarily ground, retire. The aircraft were barely 10 years old, some hadn't even reached mid-life. The stated reason was operating costs, but the real problem was route flexibility. Air France couldn't redeploy the A380s when demand shifted. The aircraft worked on exactly 3 routes. When business travel collapsed during COVID-19, those routes couldn't sustain 500-seat operations. Smaller aircraft could adjust, the A380 couldn't. Lufthansa followed. The German carrier had ordered 14 A380s, operating them from Frankfurt and Munich to New York, Los Angeles, Hong Kong, and Beijing. Flagship routes for a flagship aircraft. But Lufthansa discovered the same problem Air France did. The economics only worked at high load factors. Drop below a certain point and the A380 started losing money compared to 777s or A350s. 6 of Lufthansa's A380s were parked permanently in 2020. The remaining 8 returned to service briefly, then were grounded again, then returned again. Thai Airways retired all 6 of its A380s. The Thai flag carrier had configured them for Bangkok to London, Frankfurt, Tokyo, and Sydney. The aircraft couldn't fill 500 seats reliably, even before the pandemic. When travel demand collapsed in 2020, the decision became obvious. The A380s were too expensive to operate and impossible to justify financially. Singapore Airlines, the launch customer, the airline that took the very first A380 delivery in 2007, began retiring aircraft early. The carrier had 19 A380s. By 2023, it was clear that the number would shrink. Singapore Airlines was taking delivery of smaller twins like the A350. The writing was on the wall. Even the airline that had believed in the A380 from the beginning was moving on. Then there was the ANA story. All Nippon Airways ordered exactly 3 A380s. not 13, not 30, 3. The order baffled industry analysts. The economics made no sense. Operating 3 aircraft meant dedicated pilot training, specialized ground equipment, and maintenance programs for a tiny subfleet. ANA configured the aircraft for a single route, Tokyo Narita to Honolulu, a leisure route, not a hub strategy. The cabins were designed around Hawaiian vacation travelers. The livery featured a smiling sea turtle, the flying Honu. It was adorable. It was also incredibly niche. The gamble was that Japanese tourism demand would fill 520 seats consistently. It did, briefly, but the route was too specialized. ANA had no other use for aircraft that large. When COVID-19 hit, the A380s sat grounded for over 2 years. The airline couldn't redeploy them. There was nowhere to send them. The pattern was unmistakable. Airbus couldn't make the economics work outside of a few ultra-high-demand routes. Even airlines that loved the passenger experience and passengers genuinely loved flying the A380 couldn't justify the operational costs. Resale value collapsed. Used A380s became nearly impossible to sell on the secondary market. Lessors who had financed aircraft for airlines discovered they were holding stranded assets. No one wanted them. The aircraft were too large, too expensive, too inflexible. Some A380s were scrapped for parts before reaching 15 years of service. Engines, avionics, landing gear, stripped and sold to keep other A380s flying. Aircraft that cost over $400 million new were being parted out like old cars in a junkyard. By 2019, the trend was undeniable. Airlines were retreating from the A380 en masse, and Airbus, they had no choice but to face reality. February 2019, Airbus drops the announcement that everyone saw coming, but no one wanted to hear. A380 production will cease in 2021. The trigger was Emirates, the airline that had kept the program alive, that had ordered more A380s than everyone else combined, couldn't justify taking more. Emirates reduced its outstanding order and made it clear there would be no further purchases. Without Emirates, the program was dead. No other airline was ordering in meaningful numbers. The backlog had evaporated. The final tally was brutal. Only 251 aircraft delivered over 14 years. Airbus had projected over 1,200 sales when the program launched. The break-even point was far off. Financial losses were staggering. Estimates suggest Airbus lost billions on the A380 program. Development costs exceeded $30 billion. Production costs never achieved the economies of scale needed to make individual aircraft profitable. The wiring crisis alone cost over $6 billion in delays and rework. Every A380 delivered likely cost money. The program was sustained by European government loans and the hope that future orders would eventually justify the investment. Those orders never materialized. The final deliveries trickled out through 2021. The last A380 was handed over to Emirates in December, tail number A6 EVS. The aircraft that was supposed to revolutionize aviation ended production with a whimper, not a celebration. Airbus made it clear there would be no successor, no A380neo with more efficient engines, no stretched variant, no freighter version. The era of the superjumbo was over. Boeing's 747 ended production in 2023. The Queen of the Skies and the aircraft that tried to replace it both disappeared within a year of each other. The 4-engine widebody was extinct. The market had spoken with absolute clarity. Airlines wanted fuel-efficient twins, aircraft that could serve multiple routes profitably, planes that offered operational flexibility, not maximum capacity. The A380's failure, it wasn't about bad engineering. The aircraft performed flawlessly. Passengers loved it. It set records for comfort, quietness, and operational reliability. The failure was strategic. Airbus bet on a future that never arrived. They assumed hub dominance would continue, that slot constraints would force airlines toward larger aircraft, that passengers would accept connections over direct flights, that 4-engine economics could remain competitive against twins. Every assumption proved wrong. ETOPS regulations eliminated the need for 4 engines on long overwater routes. Point-to-point networks fragmented the hub model. Passengers chose frequency over capacity. Fuel prices made twin-engine operations dramatically more economical. The A380 was designed to dominate a world that was already disappearing. By the time the first aircraft entered service in 2007, the market had moved on. While they were not flying just yet, at that time, the 787 Dreamliner and A350 represented the future. Medium capacity, long range, operational flexibility. Airbus built the ultimate hub aircraft for an industry that no longer wanted hubs. They created the perfect solution to a problem that was solving itself through different means. The production line in Toulouse fell silent, the massive assembly jigs were dismantled, the specialized tooling was stored or scrapped. The facility was repurposed for A321neo production, single-aisle aircraft that airlines actually wanted. The A380 became a monument to the danger of betting against market forces. No amount of engineering excellence can overcome strategic misalignment. So, what's the legacy of the A380, and what does its failure teach us about the future of aviation? Here's the paradox. The A380 succeeded as an aircraft. Passengers consistently rated it as their favorite widebody. The cabin was quieter than anything else in the sky. The ride was smooth. Airlines that configured it properly created experiences no other aircraft could match. Onboard showers, bar lounges, suites with closing doors. From an engineering perspective, the A380 was flawless. It performed exactly as designed. Fuel burn per seat was competitive with smaller aircraft. Dispatch reliability was excellent. Safety record was perfect. Not a single hull loss in commercial service. But it failed as a product. Airlines couldn't fill it consistently. They couldn't afford to operate it profitably on most routes. And they couldn't adapt it when market conditions changed. The trap was simple. Airbus assumed the future would look like the past. Bigger hubs, bigger planes, more connections. The logic seemed bulletproof in the 1990s when the program launched. Slot-constrained airports needed higher capacity. Traffic was growing exponentially. The hub-and-spoke model was the foundation of global aviation. Instead, the future was flexibility. Smaller planes that could serve more destinations, direct routes that passengers preferred over connections, the ability to adjust capacity quickly when demand shifted. The A380 was too big, too late, and too expensive, but more fundamentally, it was too specialized. It required perfect conditions to succeed: high load factors, premium demand, slot constraints, hub dominance. Remove any one of those factors and the economics collapsed. The aircraft will fly for decades in Emirates' fleet. A handful of carriers will keep them in service on specific routes, where the capacity justifies the costs. But the A380 will always be remembered as aviation's most expensive lesson, a reminder that market timing matters more than engineering brilliance, that strategic assumptions must be constantly tested against reality, that betting against flexibility is betting against the future. Have you ever flown on an A380? What did you think of the experience? Drop a comment below, because while passengers loved it, the airlines couldn't make it work. The A380 wasn't a failure of design, it was a failure of timing. And in aviation, timing is everything. Hey, before you go, the YouTube algorithm thinks you're going to like this video next, so why not check it out?